So with the permission of our colleagues from IPEN, we will now launch this event. Excellencies, dear colleagues, welcome to this new Big Plastic Pollution Dialogue co-organized with IPEN. Those of you who regularly join us already know that these dialogues kick off in 2020 to make links with ongoing multilateral processes to tackle plastic pollution in Geneva and beyond. This third series of dialogues kick off after the adoption 2 years ago of a historic resolution at the United Nations Environment Assembly, setting up the path to a global treaty to end plastic pollution. While all eyes are on the Intergovernmental Negotiating Committee to develop this international legally binding instrument that was set up following the adoption of the resolution and which will meet for its fourth session, referred to as INC4, in less than 2 weeks in Ottawa, Canada, today's event is the occasion to remember that in the multilateral system, we have other processes contributing to tackling plastic pollution. We have hosted in the run-up to INC4 10 dialogues linking to the trade, human rights, nature conservation, finance, and other negotiations ongoing in multilateral Geneva and beyond. For our last dialogue ahead of INC4, we are discussing opportunities to protect children's health and their future in the Plastics Treaty. If the circumstances allow, we are delighted to be joined by our colleagues from the World Health Organization. The World Health Organization and its World Health Assembly have indeed an important role to play in addressing plastic pollution and supporting the INC process. Let me also remind our audience that the dialogues are organized by the Geneva Environment Network in collaboration with the Basel, Rotterdam, and Stockholm Convention Secretariat, the Center for International Environmental Law, the Global Governance Center at the Graduate Institute, IUCN, the governments of Norway and Switzerland, the Forum on Trade, Environment, and the SDGs, and the University of Geneva. This session will be moderated by Pamela Miller, the Executive Director of Alaska Community Action on Toxics and IPEN co-chair. Before you are formally welcome, let me remind you that the documents presented, the summary, as well as the video of the event will be made available on the webpage of this event. Throughout the event, you can raise your questions by using the Q&A box. Interpretation is provided to Spanish and to French, and you can check the slide on your screen on how to access it. The transcript is also available in 100 languages, as indicated in this slide. Moving to the opening of this event, we are delighted to give now the floor to Pamela Miller.
Thank you so much, Diana, and good morning, good afternoon.
We lost Pamela. So these are the... She might not have realized that we have lost her, so maybe I can suggest that Maureen.
Yes, hi. Thank you all, and I can text Pam also and let her know.
I will text and you take over the moderation.
Okay, all right. Well, welcome everybody. I'm Maureen Swanson. I'm the co-director of Project Tender. Project Tender is a collaborative of more than 50 scientists, clinicians, and environmental health advocates working together to protect children's developing brains from neurotoxic chemicals and pollutants that can contribute to neurodevelopmental disorders. Of our panelists today and moderators, Pam Miller, Linda Birnbaum, and Tom Zeller are all part of Project Tender. We're so pleased that you're all here with us today, and we'd like to thank IPEN and the Geneva Environment Network for hosting this webinar and pulling everything together. Let's see. Let me
Stockholm Convention. So
There's
Serge,
Pam.
we would like to give you the floor.
Maureen, you can continue because I'm not sure Pamela realized that we lost her.
Oh, can you hear me? I'm sorry. I don't know what happened.
There's Pam.
Could you hear my introduction? No?
No, we missed it, Pam. Go ahead.
Oh dear. Well, I would just say thank you, especially to Diana and the Geneva Environment Network. And this is really an opportunity for us in advance of the INC4, the Plastics Treaty, to understand the latest science. And we have a great panel of both scientists and policy expertise represented on this call. And this knowledge then requires the need for strong, bold, and urgent action to address the threat to children's health. So thank you everyone again, and I would be glad now to turn the floor over to Serge.
You hear me?
Yes. Hi, Serge.
Yes. I don't know in which language I could provide my comment in English or French, but okay, I will make a comment in French, maybe. Okay. Déjà, bonjour, bon après-midi pour l'ensemble des participants. Je voudrais remercier IPEN d'avoir à la fois organisé ce webinaire et de me donner, de dire un mot à cette occasion. J'ai préparé juste 2 slides. Certainement, si la technique est prête, ils peuvent le projeter le deuxième slide. Next. Ma présentation va... Oui, exactement. OK, merci. Ma présentation sera le résumé des idées clés qui sont résumées ici. Et je commencerai par dire que certainement tous ici, on sait que la gouvernance mondiale des produits chimiques et des déchets dangereux est certainement marquée aujourd'hui par des résultats importants obtenus dans la mise en œuvre de la Convention de Stockholm sur les polluants organiques persistants, ainsi que les conventions de Bâle, de Rotterdam et récemment de Minamata, qui fournissent un cadre pour protéger la santé humaine et l'environnement contre les produits chimiques et les déchets dangereux grâce à une approche fondée sur le cycle de vie. 20 ans après l'entrée en vigueur de la Convention de Stockholm sur les POPs, la majorité des États membres du système des Nations Unies ont ratifié cette convention et la mettent en œuvre, ce qui, de mon point de vue, témoigne de l'importance de son objectif, qui est de protéger la santé humaine et l'environnement des effets néfastes des POPs. Au regard des informations publiées par le secrétariat de la Convention de Stockholm, au titre de l'échange d'informations, force est de constater que l'exécution d'actions significatives pour l'atteinte des objectifs assignés à de nombreux pays, parmi lesquels les pays africains sont significatifs. Toutefois, quand on examine de façon approfondie cet engagement, on constate un gap entre le temps d'évaluation des produits chimiques potentiellement dangereux, qui sont, si je peux me répéter, plus nombreux chaque jour, et la prise de décision par la COP pour l'élimination ou la restriction de production. Ce temps imparti n'est malheureusement pas pris en compte lorsqu'il s'agit de mesurer l'impact sur la santé publique, sur la santé et l'environnement. De même, il est difficile d'établir la responsabilité juridique des impacts négatifs qui en découlent. Nous avons en mémoire le cas de figure qui concerne les biens marchands électriques et électroniques dont les additifs au plastique sont listés comme POPs. On peut pour cela citer les retardateurs de flammes bromées, dont certains sont bannis ou restreints d'usage par la Convention, alors qu'un grand nombre restent autorisés en attendant les décisions politiques malgré les évidences de recherche scientifique. Et on peut ici comprendre que leur utilisation continue. Voilà. Au niveau régional, c'est-à-dire la région Afrique, malgré l'existence d'accords comme la Convention de Bamako, le problème n'est toujours pas résolu, c'est-à-dire le problème du contrôle des biens marchands qui contiennent des matières plastiques dangereuses ou d'autres produits chimiques. Ces quelques dernières années, le Conseil des ministres africains en charge de l'environnement, qui est la plus grande instance décisionnelle politique en matière de gouvernance de l'environnement en Afrique, a pris la décision de renforcer des actions nécessaires au contrôle et à l'évaluation des effets des produits chimiques dangereux. C'est en cela qu'un plaidoyer est important pour circonscrire les risques tout au long de leur cycle de vie. Alors, dans le cas spécifique du Gabon, pour parler des succès, l'expérience de la mise en œuvre de la déclaration de Libreville sur la santé et l'environnement en Afrique, qui est une action fortement soutenue par l'OMS et le PNUE, cette initiative a permis d'identifier et de sécuriser près de 100 tonnes de PCB, de POPs de type PCB, avec le soutien du mécanisme financier de la Convention de Stockholm, qui est hébergé par le GEF. Ce succès, pour ceux qui étaient à la dernière conférence des parties à la Convention de Stockholm, ont remarqué que le secrétaire exécutif de la Convention de Stockholm, M. Rolf Payet, a primé le Gabon pour ses efforts en termes d'élimination des POPs, notamment des PCB. Donc, pour dire que l'expérience de la mise en œuvre de la Convention de Stockholm a, de mon point de vue, mis en exergue aussi bien dans le cas spécifique du Gabon que dans le cas de l'Afrique, l'importance de la synergie des acteurs pour résoudre les problèmes environnementaux. En effet, les résultats obtenus de façon particulière au Gabon sont le fruit d'une étroite collaboration entre divers partenaires, notamment les agences des Nations Unies, parmi lesquelles l'OMS, pour ne pas le citer, et le PNUE, sous l'appui financier du GEF. Dans leur stratégie d'accompagner les actions de protection de santé et de l'environnement, notamment la mise en œuvre de la déclaration de Libreville sur la santé et l'environnement en Afrique, les soutiens techniques et financiers ont été mobilisés pour la création dans 9 pays africains, dont le Gabon, des observatoires intégrés pour la prévention et la gestion des risques chimiques, qu'on appelle communément CHEMOPS, africains. Donc, un des résultats de ce projet consiste à éliminer les tonnages de PCB identifiés et sécurisés au Gabon. Donc, on comprend que c'est quand même une action significative en termes de mise en œuvre, en termes d'expérience, d'obtention des résultats au titre de la Convention de Stockholm. Alors, contrairement à d'autres conventions qui traitent des produits chimiques ou des déchets dangereux, nous pouvons dire, sans risque de nous tromper, que la Convention de Stockholm est effectivement mise en œuvre en dépit des contraintes parfois qualifiées de non-respect, parce que c'est communément le terme qui est utilisé lorsqu'il faut évaluer l'efficacité de la Convention. Alors que de nombreux pays, notamment les pays en développement, disposent des NIP initiaux et des NIP actualisés comme indicateur de leur ferme volonté de mettre en œuvre la Convention de Stockholm, l'élimination effective des POPs ainsi que leur identification dans les biens marchands reste à la fois très onéreuse et difficile puisque les capacités techniques de destruction et des études scientifiques sont quasi inexistantes, ce qui traduit l'insuffisance des moyens disponibles à travers le mécanisme de soutien à ces pays. Alors, pour faire le lien entre le futur traité en cours de négociation sur le plastique, le Gabon a conduit en collaboration avec IPEN. C'est l'occasion aussi de remercier ce partenariat-là. Je disais tantôt, le Gabon a conduit en collaboration avec IPEN une étude sur la présence des POPs dans les jouets pour enfants et les ustensiles de cuisine en plastique qui sont vendus sur le marché gabonais. Les résultats de cette étude ont montré la présence de fortes teneurs en POPs retardateurs de flammes bromées, surtout dans les jouets pour enfants. Sur ce point, on voit l'importance de mettre un accent sur l'élimination des substances chimiques préoccupantes dans les plastiques et la nécessité d'un recyclage non toxique, si tant est que le recyclage peut être une partie de la réponse à la pollution plastique dans le futur traité qui vise à mettre fin à la pollution plastique d'ici 2040. C'est en cela que le futur traité, en termes de conclusion, c'est en cela que le futur traité sur le plastique offre une opportunité unique de protéger la santé humaine en éliminant toutes les substances chimiques préoccupantes tout au long du cycle de vie des plastiques, ainsi qu'une transparence accrue sur les produits chimiques utilisés. En cela, une coopération et des synergies entre le futur traité et la Convention de Stockholm en particulier, et les autres accords multilatéraux sur les produits chimiques et les déchets dangereux seront déterminants pour atteindre cet objectif de protection de la santé. Je ne finirai pas sans préciser que l'efficacité ou l'effectivité de la mise en œuvre de ce futur traité sera conditionnée par un financement, un soutien financier et technique pour la mise en œuvre du traité en faveur des pays en voie de développement. Voilà résumé les quelques mots que vous pouvez produire à l'occasion de ce webinaire. Je vous remercie.
Thank you so very much, Serge. And since I cut out in my introduction, I just want to thank you for joining us today. Thank you so much for sharing your years and decades, really. Very much. And I believe that Maria Nera and Mohammed will not be able to join us today. So I will pass it to Maureen Swanson. Maureen is the Director of Environmental Risk Reduction and Project Tender with the ARC. And Maureen, thank you so much for helping us to organize this today as well.
Thank you, Pam. We'll get started with our presentations. As I mentioned, Maureen Swanson, I'm the co-director of Project Tender, and we're a collaborative of scientists, clinicians, and advocates working to protect children's brains from neurotoxic chemicals and pollutants. Our first speaker today is Dr. Andrea Gore. Dr. Gore is a professor of pharmacology and toxicology at the University of Texas at Austin, and she will be speaking on endocrine disrupting chemicals in plastics. So I will turn things over to Andrea.
All right, thank you, and bon matin or bonjour to everyone. So today I'm going to be focusing on developmental and multi-generational effects of endocrine disrupting chemicals, EDCs, as I'll call them, in plastics. Next. So just to call your attention to the latest guide to EDCs, Threats to Human Health, that was recently released by the Endocrine Society and IPEN in collaboration. And the link is in the chat. Next slide. So let me begin. There are chemicals in plastics that are EDCs, and EDCs are those chemicals that interfere with hormones and their actions. Hormones in our body are required for the normal regulation of growth and development, metabolism, responding to stress, reproduction, as well as other functions. And when these functions are perturbed by EDCs, this can lead to endocrine disorders such as diabetes, obesity, cardiovascular problems, reproductive disorders, certain cancers, and even brain and behavioral problems, as will be a theme of this conference, because the brain is extremely sensitive to the body's hormones. Next slide. So in the IPEN Endocrine Society guide, we focused most on bisphenols and phthalates as the classes of EDCs that are very commonly and still are used in chemicals. Over the last decades, the science on how plastics contain EDCs, which ones are there, and how they act has grown, as well as our understanding of how important the environment is in the prevalence of disease. In fact, most human diseases are either caused or exacerbated by environmental factors as opposed to the genetic underpinnings. There is a convergence of research from studies using cell lines, animal models, and epidemiological studies in humans that have led to very strong evidence and very strong confidence that exposures to bisphenols and phthalates can lead to detrimental health outcomes. And numerous international scientific and medical organizations have called for stronger regulations. So along with the Endocrine Society, most of the international pediatrics, other endocrine organizations, reproduction and OBGYN groups, andrology groups, thyroid groups, are calling for these regulations in recognition of their effects of these chemicals on endocrine systems. Next. And the focus of my next few minutes will be that EDCs in plastic threaten vulnerable populations. Of course, when we're exposed to EDCs at any stage of our lives, we're liable to develop some sort of adverse outcome. But we're particularly concerned about periods of development when the body is changing rapidly and where exposures to hormones are very tightly regulated, and even tiny amounts of hormone exposures can have big effects later on in life. And so our point of view is that EDCs pose the biggest risk to pregnant women and the fetus during pregnancy, to young children, to people going through puberty when hormones are also rapidly changing. And we know that there are exposures within the womb and to infants because bisphenols and phthalates can both cross the placenta and get to a fetus. These chemicals are detectable in amniotic fluid and umbilical cord blood. And so there is direct exposure of these developing people to these chemicals. And there's also exposures of the mothers, and those can also change their hormones of pregnancy. We also know that EDCs can have impacts across multiple generations. And I will talk about that in the next slide. Or let me talk about one more slide on development first. So we have a theory that we work under in this field that is called DOHAD, or the Developmental Origins of Health and Disease. And this DOHAD hypothesis posits that the timing of exposure to EDCs is key. As I mentioned, fetus, infant, child, and puberty. But importantly, the manifestation of a disease or an adverse outcome may not be observed for years or even for decades. Take as an example, exposure to an EDC in the womb that may change how the reproductive system develops. Well, people don't try to reproduce until they're in their 20s or their 30s, and only then might they realize that there's a reproductive problem that was potentially contributed to by early life exposures to EDCs such as bisphenols and phthalates. And we refer to these vulnerable stages as critical periods when there is the greatest developmental change in hormone sensitivity. Endocrinologists also like to use the phrase, the timing makes the poison. And I'd like to differentiate that from the phrase that toxicologists use in regulatory testing. They say the dose makes the poison, meaning a higher dose is worse than a lower dose. But we prefer the timing makes the poison because even a very low dose during a critical period can have long-term and physiologically relevant consequences. Next. So now I'll turn to intergenerational and multi-generational effects. So let me just show you in this slide how when a mother is being exposed to plastics, her child, she's holding in her arms, that would be the next generation. The fetus in her belly is also the next generation. So they are directly exposed to the chemicals. Within the womb of and within the fetus itself are the cells that are going to be developing into the sperm or the egg cells, and we call that the germline. We know now that germline exposure to EDCs, including bisphenols and phthalates, can act upon the germline, cause molecular changes, and potentially lead to further generational effects, if heritable, to the next generation, what is the great-grandchild, or in the lab we call the F3 generation. Next. One more click. And we are starting to understand the mechanisms by how that works, these multi-generational effects. So the germline, these precursors to sperm and eggs, can be programmed by EDCs. We use the word programming, affecting multiple generations. And this programming is referred to as epigenetic programming. And the way this works is that they are changes to the DNA that happen through exposure to BPA or phthalates or other bisphenols. And they're not mutations, so we're not changing the DNA sequence that encodes a gene. What we're changing are other factors around the gene within the cell that modify whether that gene is going to be expressed and whether that gene will then be turned into a protein. And the protein is the functional unit that would carry out functions in the body that would be, let's say, stimulated by hormones. Some of these mechanisms are known for heritability. They're called DNA methylation, histone modifications, and non-coding RNAs. And I won't go into any detail here, but we know now that germline exposure to EDCs can undergo any of those modifications and then transmit an adverse endocrine or neurological phenotype to the next generation. Next slide. As we know, bisphenols and phthalates are ubiquitous in the environment. And just for the sake of time, I won't read all of these places where we're exposed to bisphenols and phthalates, but they come from many different sources. And next slide. And although they're not POPs, our exposures are so ubiquitous and we are constantly being re-exposed. And so they might as well be POPs in the sense that while the chemicals themselves are not persistent, we have constant exposure to these kinds of chemicals. I'd also like to point out that when we see something that is BPA free, it almost always includes a replacement bisphenol, such as BPS, F, or AF. And those are also now known to be EDCs. And similarly, there are phthalates that are replacing other phthalates. And we call this a regrettable substitution cycle, where one similar chemical replaces another, and we're not really improving health outcomes. We also know some of the mechanisms. BPA is well studied for its effects on estrogen receptor, and phthalates for their effects on the androgen receptor, and their respective hormones are estradiol and testosterone. But these are just the tip of the iceberg on how these chemicals act as EDCs. Next. And finally, the human health outcomes that are linked to phthalates and BP and bisphenols. There is very strong evidence for direct developmental exposures and increasing evidence for intergenerational effects on brain disorders, metabolic problems like diabetes and obesity, reproductive health problems and reproductive cancers, thyroid hormone problems, and cardiovascular disease and hypertension. Next slide. And all of these are covered in the IPEN guide, the recent one, the 2020 guide on plastics, and then the 2 Endocrine Society scientific statements. So let me stop here, and I believe we will have time for questions later. So thank you very much.
Thank you, Andrea. And yes, we'll do questions on all 4 of the scientist presentations at the end. Next up, we have Dr. Linda Birnbaum. Linda is the former director of the National Institute of Environmental Health Sciences and the National Toxicology Program. And Dr. Birnbaum will be covering Project Tender's new briefing paper, Protecting the Developing Brains of Children from the Harmful Effects of Plastics and Toxic Chemicals in Plastics. And Linda, I will put the link to the paper in the chat.
You are muted.
Sorry, I guess I was starting to talk without being available. Thank you very much. I really look forward to being able to rapidly present the tender information. So if I could have my slides, it would be great. So as Maureen said, I'm going to be briefly going over the seminal paper that we just produced that Maureen has put in the chat. And the important thing here is that we really need to protect the brains of our children. And there are so many toxic chemicals in plastic. You've heard a little bit about some of the ones from Andrea Gore, but I'm going to reiterate that as well as give you a couple of more to be concerned about. So the next slide, please. So I think the thing that we need to understand when we're dealing with plastics, and this group very well may, is that it's not just the big plastics that we see out in the trash. It's all the fragments, the nanoplastics and the microplastics. And it's not only the physical issues that we have with the plastics penetrating into our cells, into our bodies, and then into our cells, but that there are thousands of chemical additives. And some of these are very well-known neurotoxicants. You've heard about the phthalates and the bisphenols. There are also the flame retardants. And I'm going to talk mainly about the PBDE flame retardants, most of which have been removed from commerce by the Stockholm Convention, as well as other regulatory approaches. However, we all have them in our bodies and we're still being exposed. And then we have many other neurotoxicants that are present. They may not have quite as much data, but we know that they do cause problems in cells, in experimental animals, and there's growing human data as well. There are other kinds of organohalogen flame retardants. There are the organophosphate flame retardants. And I could say, why would we think that organophosphate pesticides are bad for the brain of developing children? We know that that's the case. And why wouldn't we think that just because they're not pesticide, they're flame retardants, they would not also be bad for the brains of our children? There are the persistent chemicals like the chlorinated paraffins. The data for those is just starting to emerge. And then the huge class of PFAS that many of us are very concerned about, the PFAS, the and perfluorinated alkyl substances where they're everywhere and in everything and in all of us. I think the important thing is that plastics act as vectors to directly deliver these neurotoxic chemicals into our bodies and into our brains. Next slide, please. So I think it's when we talk about what are our sources and how are we getting exposed, we need to realize we're getting them from all routes. Plastics are present in our diet, and many of the chemicals leach directly from the plastic packaging, the food processing equipment. Higher levels are found in fast food than, for example, organic food, from the resins and cans and the bottles, and get into our diet and therefore into us. Now, these chemicals don't only get into our food, they get into our dust, whether it's our house dust or our office dust. And so that can be very high concentrations in dust, in the flooring, in the building products, electronics, and so on. And here we see a lot of the flame retardants as well as the phthalates. And then we need to understand that when we try to get rid of plastics, and if incineration is a huge problem, because if in fact you have chlorine and bromine, you generate neurotoxic chemicals like our old, I was going to say our old friends, that's a little cynical, but like the dioxins and the furans. And we know that children are highly exposed to things like dust, because they spend a lot of time on the floor, they constantly mouth things and put things in their hands. And young children breathe and eat and drink a lot more relative to their body weight than adults. Next slide, please. So we can find actually pieces of plastic, the microplastics and the nanoplastics, and we can find these chemical additives in the plastic in the placenta. And the placenta is absolutely the organ that is essential for supporting the growth of the fetus. And a recent study, in fact, found that 60% of placenta samples had plastic particles in 2006. 10 years ago it was 90%. And in 2021, every single placenta looked at had plastic particles. We can find plastic particles and some of the chemical additives in meconium, which is the infant's first stool. We find these compounds in breast milk, and we find them in infant formula as well. And again, the blood-brain barrier is a very, very weak barrier, and plastic particles can directly cross into the brain. So I'm sorry to say, but babies entered the world today with their brains and bodies contaminated with plastics. Next slide, please. So what are some of the impacts on child brain development? Well, I mentioned before that plastic particles, as well as the chemicals, can penetrate across cell membranes and impair placental function. If you impair the placenta, you're going to have problems in fetal growth. You're going to have problems in brain growth and development. And if you impact brain growth and development, you're going to have impacts on behavior, on motor function, on learning, and in memory. Now, we know that plastic particles have been found in all the placentas of low birth weight babies, but many fewer were found in normal weight babies. And babies with higher microplastic exposure had lower birth weights, shorter length, and a smaller head circumference, and a lower APGAR score. Next slide, please. So there's overwhelming evidence of neurotoxicity for several classes of chemicals that are present in plastic, and these show that prenatal and early childhood exposures contribute to problems with child brain development and neurodevelopment disorders. And I'm briefly going to go through phthalates, the PBDE flame retardants, and the bisphenols. And these chemical classes and their substitutes, as I've already said, leach into our food and into the dust. We're finding them in pregnant women, in infants, in children. And as I mentioned, they do cross the placenta and access the infant via breast milk and formula. Next slide, please. So for phthalates, Andrea's gone through some of this evidence. Why do we have phthalates? Well, because they make plastics more flexible and more durable. They're used in food packaging and production materials, personal care products, floorings, wall coverings. I should also say all kinds of medical devices. But youngest children, in fact, have the highest level of phthalate exposure of any group in the population. But we know today that diet accounts for more than 50% of the exposure, at least in the US. And we know that prenatal exposure to phthalates is associated with impacts on IQ, behavior, attention, and there are repeated studies showing links to attention deficit hyperactivity disorder. I think some of the most interesting and concerning evidence is that phthalate exposure prenatally can also affect the brain structure. So you can actually measure changes in brain volumes, and these are linked to IQ deficits. Now, I'm not going to talk about all the other things that phthalates can do prenatally. I'm focusing on the brain. I think it's important to remember that we have this whole history of unfortunate substitution, and emerging evidence is showing that the replacement phthalates also harm child brain development. Next slide, please. Now, the organohalogen flame retardants are a huge class, but they're added to furniture, textiles, electronics, and they were added to reduce the spread of fire, or the ignition, actually, of fires. The class that we have the most information on are the PBDEs, and they are associated with learning, behavior, and intellectual impairment. And we're also finding that children who are on the autism spectrum may be more susceptible to the flame retardants than children who are not on the spectrum. Now, PBDEs, as I mentioned before, are banned internationally. The US restricts some uses of PBDEs, but the problem is they're everywhere. They're found in recycled plastic products, including toys, food containers, and food handling utensils. And I think, again, unfortunate substitution, other BFRs, brominated flame retardants, and organophosphate flame retardants have replaced the PBDEs. And these replacement flame retardants also show harm to child brain development. They impact fine motor skills, working memory, language abilities, behavior, and attention. Next slide. And we have overwhelming evidence. Again, Dr. Gore has talked about the bisphenols, but again, these are tremendously high production volume compounds that are used primarily in polycarbonate plastics, epoxy resins. They're also present, for example, in thermal paper. So your receipts, you'll get some bisphenol exposure as well. And their neurotoxicity has been extensively studied, both in animal models like rats and mice and in human studies. And I want to stress that exposure to rodents during pregnancy, infancy, or adolescence is linked to deficits in memory and learning abilities. And the human studies show that BPA, like phthalates, contributes to ADHD, autism, depression, anxiety, and cognitive disorders in children. And I think what's especially concerning is that while we started to move from BPA to some of the substitutes like BPS, BPF, BPAF, those substitutes, untested before we moved to them, show larger impacts on child brain development than BPA. Next slide. So we really have to talk about preventing regrettable substitution. As I've said, as you have phased out some of these compounds, emerging evidence shows that replacement chemicals are just as or more neurotoxic, and the levels of these replacement chemicals are increasing in the population, including in pregnant women and children. And if we're going to prevent harm to children's brain, we need to eliminate all non-essential uses of plastics and harmful classes of chemicals, rather than trying to eliminate toxic compounds one by one. Next slide, please. So Tender does have some recommendations related to the Global Plastics Treaty. We really need or suggest or actually demand that we substantially reduce and cap plastics production. And we need to eliminate move towards elimination of single-use plastics and other non-essential uses. We need to phase out use of the most toxic plastic polymers, things like polyvinyl chloride and polystyrene. And we need to phase out the addition of neurotoxic chemical classes in plastics. So we really need to have bans on these chemical plastics from food contact materials, since that is a major exposure to the population. And we need to ban the classes of toxic additives in plastics and avoid regrettable substitution. Next slide, please. We need to ban intentionally added nanoplastic and microplastics in products such as cosmetics, cleaning products, and toys. We need full transparency and full public disclosure of information, including identification and reporting of all chemicals used in plastic production, as well as plastic additives. We need to ensure that disposal and recycling of plastics does not result in toxic substances, and that toxic substances are not present in recycled plastics. And we need to prevent incineration. I mentioned before that can lead to the generation of dioxins and furans, but we need to prevent it of all plastics, including chemical recycling, advanced recycling, and waste to energy schemes. Next slide. So we need a plastic treaty that protects the health of all people, but especially our children. We call for a strong plastics treaty that protects the health of children's developing brains by reducing the production and use of plastics and subsequent generation of plastic particles, and by preventing the harmful effect of plastics throughout their life cycle. Thank you, and I look forward to questions at the end.
Thank you so much, Dr. Birnbaum. Next, we will have Dr. Tom Zeller. He is a professor emeritus in the biology department at the University of Massachusetts, Amherst. And Dr. Zeller will be speaking on how chemicals in plastics interfere with the actions of hormones that are critical for child brain development. So I'll turn things over to you, Tom.
Excuse me. Well, so what I'm going to do is focus to provide a little bit of mechanistic information to just provide a good idea of what other talks have been showing clearly. So if I can have the next slide. So first of all, I want to talk a little bit about how hormones work. Hormones can only act on cells that have the right receptor. This receptor is a protein that can be either on the outside of the cell or the inside. It's often thought that the affinity of the receptor for a chemical or the hormone is the same as potency or defines potency, but this is not correct. If I can have the next slide. One thing that this graph shows here, if you look at, for example, the agonist or hormone concentration of 10 to the minus 7th molar and follow the line upwards, it shows that a cell that has more receptors has a greater response. In addition, to only achieve 10 or 20% response in the cell, you need less and less agonists by many orders of magnitude to create that as cells have more receptor numbers. What this means is that different tissues are differentially sensitive to hormones, as well as sensitive at different times during development. But it's also true that they are differentially sensitive to endocrine disrupting chemicals or neurotoxicants in the case here. Next slide. So I want to talk a little bit about thyroid hormone, because we know that thyroid hormone is essential for brain development and for physical development. Thyroid hormone contains iodine, and iodine deficiency in human populations globally is the single greatest known cause of brain damage, and that brain damage is not reversible. Fetal brain development requires thyroid hormone even during the first trimester of development. This is before the fetus can make thyroid hormone on its own, which means that the only source of thyroid hormone is the mother. Having said that, it's still important to recognize that thyroid hormone is essential throughout development, especially during the neonatal period. Next slide. So this is just kind of an example to show why Dr. Gore's statement about how timing makes the poison is true for EDC. These are mouse embryos at 2 different times during development, embryonic day 11.5 and 12.5, just 24 hours different. The blue color here represents where the thyroid hormone receptor is being activated. If you look at the eye, you can see that on 11.5, the eye has no activation of thyroid hormone receptor, but on 12.5, it's quite abundant. And this just kind of illustrates how timing is so important for proper development. Can I have the next slide? This is also expanded kind of in a review article with Joanne Rovette, who has worked for many years on human populations with thyroid hormone insufficiency. What this shows is that thyroid hormone insufficiency at different times during development produces different deficits in various cognitive function, visual processing, gross motor skills, executive function, etc. The same is true in animal studies that have looked at different elements of brain development. Next slide. So what we know for certain, you're going to have to go through several clicks here. Interfering with hormone action during development will have permanent consequences. You simply cannot reverse problems in development that occur early on. Next click. People listening to this talk, for example, would not have the intellectual capacity to understand it if you had been deficient in thyroid hormone during development. It's clear that early on, when children were born without a thyroid gland, if they had not been identified and treated soon enough, their IQ would be in the 50s rather than a normal of 100. You wouldn't have the intellectual capacity even to develop your career. And if you think about this, next click, the impact that you've had on your scientific or other discipline wouldn't be the same. And so this really represents an existential threat. Next click. Plastic chemicals that interfere with thyroid hormone system represents this existential threat because it severely reduces our ability as a human population to function. Next slide. So we've talked about kind of a traditional view of the hypothalamic pituitary thyroid axis, but it's important to recognize that this is a very complex system that requires even mechanisms within individual tissues that control thyroid hormone action. One of the outcomes of this recognition is that toxicants can interfere with thyroid hormone action in selective tissues without affecting hormone levels in the blood. So we can't assume that hormone levels or changes in hormone levels for thyroid hormone in the blood is predictive of changes in hormone action in various tissues. So this represents a very complex issue that is difficult to identify in all cases. Next slide. So plastic chemicals are known to interfere with the thyroid hormone system. You've heard about phthalates, bisphenols, also triclosan, halogenated flame retardants, and PFAS. And while these represent just a few of the chemicals that are known to be in plastics relative to the estimated 16,000 different chemicals that are used to make plastics. They're important because we are all contaminated with these chemicals. So I think, go ahead and next slide. I think I'll leave it there and I'll be happy to answer questions after the next presentation.
Thank you, Dr. Zeller. And now, wrapping up our scientific presentations, we will have Dr. Leo Tresande. Dr. Tresande is a professor of pediatrics and director of the Center for the Investigation of Environmental Hazards at the New York University Grossman School of Medicine. And Dr. Tresande will be speaking on preterm births linked to plastics chemicals and associated costs. So go ahead.
Thank you for the opportunity. I don't have slides because I see this as an opportunity for engagement in a deeper way here, and others have really set the stage beautifully for what I'll talk about. So most of the presentations have focused on children's learning and development and the consequences of chemicals used in plastics in particular. And as Dr. Birnbaum described so eloquently, we visually put our attention most firmly on what we can see in oceans and now in human specimens in the form of microplastics. But it's more than likely that the reason why microplastics are a problem is that they are the chemical carrier pigeons, ultimately, and deliver toxic drugs to key organ systems crucial for children's learning and development. Perhaps we should have known this given the advent of nanotechnology as a therapeutic pathway for delivery of drugs into people's bodies. And by the same token, nano and microplastics can deliver toxic chemicals that don't just affect children's brain development, but affect all sorts of organ systems that span the life course. Dr. Birnbaum also described studies documenting the presence of microplastics in the placenta. And when you see microplastics, you see a much larger array, ultimately, of chemicals that are absorbed directly and cross the placenta and into children's bodies. And it's not just effects on thyroid development and developing brains that are a problem. Those chemicals used in plastic materials disrupt hormonal function in the placenta and contribute to inflammation directly in the placenta. And the placenta is the organ that keeps gestation going. And every week in a child's gestation is crucial, not just for brain development, that's a big deal, but ultimately for development of all sorts of organs. And the effects of a shorter gestation are permanent and lifelong. That's why we focus most keenly on prolonging gestation all the way to term. And we know that children who are born preterm don't just have cognitive deficits. They ultimately have long-term cardiovascular and metabolic risks all the way into adulthood. And when you have inflammation in the placenta, you limit blood flow to key and vital organs. And we learned in the aftermath of World War II that there are these developmental origins of health and disease that Dr. Gore described. And the work of the late Sir David Barker documented that when you disrupt fetal growth, the consequences can be as significant as cardiovascular mortality and even stroke. And it's not just gross disruptions of fetal growth that can have those consequences for adult health. We know that subtle consequences, such as the ones we're talking about here, with low-level chemical exposures, can disrupt subtly key moments in fetal growth and then reverberate longer term through a thrifty phenotype in which the child out of the womb is avidly absorbing calories in a way that has adverse consequences for obesity as well as heart disease. But I'm going to bring it back to how I was introduced, which is that we have done a study documenting phthalate exposures in a large sample of American children, spanning 5,000 children from across the country. And what we found here really covers two themes. One is that chemicals, as they're introduced in plastic, whether we replace one chemical with another, have the same consequences, in even potentially worse consequences for prematurity. Some of the older phthalates used in food packaging, such as di-2-ethylhexylphthalate or DEHP, had already been associated with prematurity and shortening gestation. What we found in this large study published in Lancet Planetary Health this year is that the replacement phthalates, DINP, DIDP, DNOP, were all even more strongly associated with shortening gestation and increases in premature birth. And the second thing is the substantialness of the impact of phthalates on premature birth. We're talking about 5 to 10% of all premature births in the United States, extrapolated based on current exposures we see in the US. And let me be clear, the global consequences are likely as similar. It's just a question of documenting the exposures to phthalates. And what we found is that the costs of these premature births are in the range of $5 to $8 billion a year. That's an annual cost insofar as exposures continue at current levels. Now, this adds to the cost of disease and disability ultimately that can be traced to chemicals used in plastic exposures. In the Journal of Endocrine Society, we published a paper this year isolating the disease burden and cost that can be traced ultimately to chemical used in plastic. And what we found were costs on the order of $250 billion a year. That's separate from that $8 billion cost in the United States alone. And that was based on less than 1% of chemicals used in plastic, a subset of diseases due to the few chemicals we studied, and a subset of costs due to the few diseases due to the few chemicals we studied. So this is an extreme underestimate of the broader consequences. And just isolating in the United States, if you extrapolate globally, we're talking potentially in the range of trillions of dollars of economic costs due to disease and disability, especially in children, because the largest driver of those $250 billion in costs were ultimately adverse effects on brain development. So by way of what we need to do now, we need to get serious, as others have said, about reducing our use of plastic, particularly our production of plastic, but our use of plastic, period. Because recycled plastic can accumulate greater amounts of chemicals, as have been demonstrated in previous studies. So the whole recycling notion is a fig leaf of consumerism. Insofar as we don't reduce our use of plastic, we won't reduce the disease burdens that I've talked about, because the chemicals will be there from the plastics and will be drug delivered ultimately into children's lives, but ultimately in all of us. So we need to reduce our production of plastics, period. We also need to simplify the chemical composition of plastics. We have 16,000 chemicals used in plastics today. We can't study all 16,000. What little we know about 20 to 30 suggests huge consequences that I've described here for human health and for the economy. And ultimately, if we go testing every single one of these chemicals, I fear we will have an even greater consequence for human health than what I've described. It really speaks to the need to hone in on a subset of chemicals that are truly identified as safe, ultimately. And we need to put the burden of safety on the chemical rather than on people's lives. And ultimately, we, as I've alluded to, need to identify and follow, as the Plastics Treaty is implemented, what chemical exposures from plastics are like in low and middle income countries in particular. We have extreme gaps in data in what is the burden of disease and disability and the exposure, frankly, as a result of chemicals used in plastics. So we need to have a biomonitoring system put into place to document chemical exposures of concern. And we need to build more science. We need a global infrastructure, ideally through an equivalent of an international agency for research in plastic chemicals, in particular endocrine disrupting chemicals. That's really going to be our pathway to pass a legacy on to the next generation of children that is better for the first. So thank you for the opportunity, and I look forward to the question and answer session.
Thank you, Dr. Tresande. I just want to say thank you again to all 4 of our scientists who gave and physicians who gave presentations today. You know, your presentations fit so well together and built this comprehensive and nuanced picture that is emerging of what is happening to children and their health and development as a result of exposures to plastics and the toxic chemicals in plastics. And I'd like to note that although all 4 of our researchers today, our presenters, are from the United States, the science itself, of course, is being done globally. And if you look at some of the references with any of these papers, the Endocrine Society paper and the papers and reports in the Project Tender paper, you'll see that this science is happening all over the globe. And of course, our presenters today work collaboratively with colleagues in many different countries. So the scientific picture is emerging in every country, I believe. Before we go to questions and answers, we're going to turn to Dr. Maria Niera with the World Health Organization. And we're so pleased that Dr. Niera has been able to join us today. And so I'll turn things over to her, and then we'll go to questions and answers after that.
Thank you. Thank you very much, Maureen. And thank you all for this fantastic panel and scientific presentations. Let me just disclose an information. I'm an endocrinologist myself, and therefore, as you can imagine, I was very happy to hear the presentations and to feel again very close to my initial group of experts with whom I've been, you know, for many years part of that community. As the World Health Organization, and apologies for not joining you just at the beginning, we are very much supportive of the importance and outlining the importance of this treaty. Clearly, we need to, this plastic treaty will represent an opportunity to protect people's health. And that's why we will be very happy if even in the treaty there is even more recognition of the importance for public health that this treaty might represent, and not only the threats for public health. I think it will be very important as well to highlight the benefits for health that we can obtain if such a treaty is properly implemented. So we will be very happy to contribute to make sure that all the WHO's resolutions, papers, norms, standards, scientific networks can contribute to make this treaty stronger and, as I say, more protective of our human health. In fact, we see on the treaty that one of the exemptions that is proposed is for the health sector, for all the medical products, for instance. But on that, in WHO, we think that there is no need a blanket exception for those medical products. At the contrary, we are moving into the ATTACH platform, which is the Alliance for Action of Transformative Action on Climate Change and Health, where we have put in place a working group, a big initiative, a platform to reduce plastic use, to decarbonize the health sector. And we can offer a lot of knowledge and initiative and action on reducing the plastic that, of course, when it's not needed on medical devices or procurement and supplies that we use at the health sector level. And again, happy as well to use all the power that we can have all together on looking at issues like my colleagues of the Tobacco Framework Convention. They are looking at the plastic filters of the cigarettes, and they are going very much on pushing for even a ban. They have requested a group of experts to produce a recommendation regarding the potential legislation. This type of work has to complement the plastic treaty. We don't need to duplicate, or we can join forces very strongly on that. And I think all of this will be very positive and contributing to that. Let me just finish by saying that you know, this is all about prevention, and you know that prevention is always very difficult to implement, but even more when, as mentioned by Linda, I think it was, or Dr. Gore, sorry, Linda, a pleasure to see you again. And if primary prevention is so difficult, imagine when you don't see the manifestation of the disease is only occurring after years of exposure. But we need to be very pragmatic on this plastic treaty, telling people that when we don't need those plastics, they can be eliminated. And by doing so, we will be having a very positive impact and protecting people's health. So once again, reinforcing the fact that WHO is very much committed, and we will put all the health arguments, the threats and the benefits together to support a strong agreement and a strong implementation of this plastic treaty. Thank you very much, and congratulations to the presenters, and of course to you for this webinar, for this seminar on this important topic. Thank you.
Thank you so much, Dr. Niera. And before we go to Q&A, I just want to say that Pam Miller asked me to convey her apologies. She's having unexpected audio problems. And, you know, Pam is the executive director of the Alaska Community Action on Toxics organization in Alaska. She's also co-chair of IPEN, the International Pollutants Elimination Network. And Pam is a leading part of Project Tender, and she chairs our plastics work group. So she is just operates at an astounding level on so many fronts, and is also just always a pleasure to work with. And we thank her for helping to put this together, along with IPEN and the Geneva Environmental Network. We can go to the questions and answers, and I can look at the Q&A that are written, and then we certainly invite folks to chime in with their questions. And POPs is persistent organic pollutants. I see there. There's a question, are bisphenols and phthalates currently regulated by any government? And there's one answer is that many governments regulate phthalates for many uses in plastics, like toys and plastics and electronics. And bisphenols are banned in many places in baby bottles. And then there's a follow-up pointing out that it might just be bisphenol A that's banned in baby bottles, not the other bisphenols that are replacements. So if any of our panelists, our scientists, would like to address that question of government regulation of phthalates and bisphenols.
So I can address at least some of it. So for bisphenols, for example, the only regulation that I know of in the US is the Food and Drug Administration has banned BPA, and it's only BPA in baby bottles and sippy cups. The European Food Safety Authority does have regulatory limits for how much BPA can be present in food, and it is about 20,000 times lower than what is allowed in the United States. For phthalates, the Consumer Product Safety Commission in the United States has had regulatory authority for phthalates and actually tried to ban 4 phthalates in all kinds of different kinds of consumer products. That was vacated by our courts. So I am not positive what the regulations are on phthalates. I think we need to also realize that phthalates are present, for example, in many pills, as far as the coatings of pills. That was one source, and other pharmaceuticals as well. So I'm not sure about the regulation of phthalates, but it's certainly not high up there. Andrea, you may know the answer. Andrea,
I don't, but I think Leo might. He had his hand up also.
Linda, you described it beautifully. What I would simply add is that, as we've described as a theme in these presentations, we need to ban chemicals used in plastics by class. What little we know about bisphenol S, for example, is that it's as estrogenic, as toxic to embryos, and as persistent in the environment as BPA. So we could go into the 140 or so bisphenols one by one and try to ban them, or try to prove the toxicity. But how many generations will that take, and how many children will be continued to be exposed at those levels? And I have to say, I have been very public since 2014, a decade ago. It's a little embarrassing to have to say it this way, because it suggests that I've not been effective as I'd like to have hoped. Now, we should not have just banned BPA in baby bottles and sippy cups back in the 2008, I think 12 was the official FDA ban year. We need to ban all uses of bisphenols in plastics, period. That's an easy, if we were going to make a list out of this treaty of chemicals used for regulated or limited through the plastics treaty, the easy 4 categories or 5 I can imagine immediately be bisphenols, phthalates, PFAS, flame retardants, and I would include organophosphates, and the brominated categories. So that would be a great start to the treaty.
The other part of this conversation that's important is the regulation is piecemeal. Even in the US, a lot of it is state by state. And we really need to be talking about international regulation. And so that's why the plastics treaty is so important.
If I could make a point, and I don't mean to take the question in a completely different direction, but I think there might be some in the chemical industry or certain governments that might panic with that kind of ban. But the fact is, there is sustainable chemistry that is in place for many of the uses that we're talking about, including, and I failed to mention PFAS, I think, in my previous list. So I just want to make that point abundantly clear, that there are substitutes in hand and alternatives to plastic.
I'd like to bring up the point that when we don't have to talk about substitute chemicals, there are different approaches to achieve the solution that you're looking for. And I think that's something that we really need to be pushing. In other words, we really don't need more plastics, period, regardless if they don't have these 4 or 5 bad or 6 bad classes of attitudes. We don't need more plastics. And I think that, so if you talk about things like food storage containers, there are other kinds of containers that you could store food in that are not plastic, that are reusable, and that's a major thing. I totally agree with Leo's point that we have to look at classes here. There have been 350,000 chemicals synthesized since the end of World War II, and we have data on almost none of them. And even those that we have, what you find out is they're all a problem. So all bisphenols are problematic. All orthophthalates are problematic. As far as I can tell, all of the halogenated and organophosphate flame retardants are problematic. We have very limited data to say that, but that's where the data is going with PFAS. There are 15,000 of them. We have data on total data, very limited maybe in cases, on maybe 150, and they all are problematic. So we need to look at a class approach, not just one by one, but we need to remember that sometimes the approach should not say, well, we're just going to substitute another chemical that hopefully we've shown is safe. We're going to say, maybe there's another way to achieve the goal that we're setting, such as safe food storage.
Thank you all. There's a related question, which I believe has been partially answered, at least, but in many cases, there's no differential exposure to chemicals in a child among the potential sources and types of chemicals. So who can we make responsible for fixing the problem, and how do we make them responsible?
I can quickly address that. Just to say, in our paper in the Journal of the Endocrine Society, we attributed percentages of chemical exposures to plastic, and consistently those percentages were north of 70%, and in many cases were for bisphenols 99% or greater. So in many cases, when we're talking about these chemicals, we're talking about plastic as the origin story of these chemicals.
Thank you, Dr. Tresande. Another question here is, do any of the panelists have comments regarding the exposure of humans in utero through adults to the 1 to 38 pounds of PFAS and additional toxic and carcinogenic chemicals in regulation-sized synthetic turf playing fields? So a question specific to synthetic turf playing fields and toxic chemical exposures that way.
I'll take it just initially, which is there's growing evidence that there are problems with synthetic turf. It's not just PFAS. You have a lot of toxic metals, you have volatile organics. Never mind that synthetic turf is a plastic product in many cases, which is highly irritating as well. But the amounts of PFAS are concerning. We do not have good data yet how much exposure actually directly occurs, but it's problematic because even plastic turf doesn't last forever.
Thank you, Dr. Birnbaum. Here's a question. What mechanisms are currently being discussed in designing the plastics treaty to ensure that children's health is the benchmark for all goals, objectives, targets, indicators, policy, and regulatory requirements included in the treaty? And I'd open that to our panelists, and then also to some of our colleagues at IPEN and the World Health Organization, if they'd also like to respond to that.
I could start if that's okay. Having followed the multiple rounds and read the multiple versions of the zero draft, there are basic problems with some of the scope definitions options in the treaty right now. Health isn't in all of them. Children's health isn't even in all of them. There's just assumption that the scope of the treaty should just be ocean plastic. This is a production problem. This is an upstream problem, and it's a health problem. It's a human health problem. It's especially a children's health problem. So I would find it shocking if, as we go to Ottawa, the treaty scope is narrowed away from science to what we know is important. I'll stop there.
Anyone else like to respond? And thank you. That was really helpful to understand, Dr. Tresande. I see Pam, were you trying to respond as well? Not sure. Pam might be having.
Still says muted on her.
Okay. Okay. Well, let's move to, and we can certainly come back if there are people who want to chime in with answers or nuances. There are various types of plastic material. Could you please enlighten which plastics types contain these concerning chemicals?
All.
I'll take that. I had a slide on it, which I kind of rushed through, so I can just say very quickly, common places, I mean, we're exposed all over the place is the answer, but for bisphenols, it's food and beverage containers, food can linings, medical and sports equipment, even eyeglass lenses, thermal paper receipts, plastic water pipes, adhesive paints and lacquers, and for and that's just a subset. For phthalates, it's PVC products, personal care products, medications and dietary supplements sometimes have phthalates. Also food and beverage packaging and processing materials, children's toys, of course, children stick those things in their mouths all the time. And medical tubing like intravenous tubing, which is inserted into our bodies. So really it's impossible to get away from these chemicals and plastics.
If I could just add a comment, because I think there's a couple ways the question can be interpreted. Andrew, you answered one interpretation beautifully. I saw it a potentially different way, and I want to just elaborate on it. So phthalates are used most prominently in PVC plastic. Bisphenols are used most prominently in polycarbonate plastic, and styrene, a carcinogen, is a monomer in polystyrene plastics. But I just want to re-emphasize a point that I made earlier, is that recycling throws everything, particularly chemical recycling, is a particularly awful way to introduce chemicals into plastic materials that run across the 7 recycling categories. So the assumption that we can keep chemicals used in plastic in just a particular subtype of plastic is flawed on the basis of recycling alone. So I just want to make that point rather emphatically.
Well, I'd like to just add on, and Leo just didn't tell us the bad information or the negative findings that we all know, that less than 15% of plastic is ever recycled, and that only gets recycled once.
Thank you. There are some other questions involving regulations. How do we get the United States Food and Drug Administration to ban chemicals by class? I don't know if anybody wants to take that. And then there's a question, a different sort of question that we'll move to next. I know we've got limited time. So if anybody wants to say something about the FDA.
I'll just say that there are many of us who are working through various channels to try to get the Food and Drug Administration in the US to be more proactive related to contaminants in food, and it's an uphill battle. That's all I can say. I mean, the differences between FDA's approach and EFSA's approach are dramatic and depressing for an American.
Yes.
May I add, the FDA doesn't even admit that BPA is a problem. They still think that there are safe levels of BPA. So we have not gotten very far there, considering BPA was the prototype.
And the reason that FDA finally banned BPA's use in baby bottles and sippy cups was not because they thought it was a problem, but because after the marketplace, basically women stopped buying BPA containing bottles and sippy cups. The chemical industry sued FDA to ban those uses of BPA. So it was kind of a cynical way of not dealing with the problem.
Wow. We could do a whole nother webinar on working on FDA to address these toxic chemicals in food contact materials. And then the last question, as we're at time here, but it's kind of a different angle. Do you think that pressure on manufacturers from investors for fear of litigation, for example, with PFAS, is a positive move?
I'll take that also, and someone else obviously is welcome to, but the answer is I think it is. We know that 3M, about a year and a half ago, announced that they would no longer make any, and 3M is was one of the largest international producers of PFAS, and they announced that by 2025 or the end of 25, they would not only no longer make any PFAS, but they would not use any PFAS in their product. And 3M has recently been hit with some very major lawsuits and has agreed to a settlement of about $12.5 billion related to the contamination of drinking water supplies. Now that's a drop in the bucket, but if you look at the amount that litigation is costing related to the profits of many of these companies, if it starts getting above a certain point, they start looking to divest. But I think that the thing that drives the industrial decision-making most rapidly is consumer demand and consumer arguments. And I have to go back, someone made the comment that, I think Andrea, that in the US, we have often, the states will regulate, but the federal government will. If it weren't for California and a couple of other states, we'd be in much worse shape than we are now, because no producer wants to make something that they can't sell in the world's 5th largest economy.
Thank you, everybody. And I see there's a question about measuring sources and references on measuring leaching of toxic chemicals from microplastics. And so if that person, I emailed and asked you, or I responded with my email address. So if you'll email me, I can put you in touch with some of those studies and references. Thank you so much, everyone. This has been an outstanding panel of experts, and clearly, we've all got our work cut out for us in trying to influence the Plastics Treaty to have a frame of protecting children's health. So we very much appreciate everyone's participation and engaging talks on your research, and the Q&A was extremely helpful too. Thank you very much. And I don't know if our IPEN and Geneva Environment Network colleagues want to say something in closing.
We just want to thank you all. I don't know if our friends from IPEN want to add something, but thank you very much. It was really a great input for who still had doubts that there was a health issue related to plastics. I think there's a lot of food for thought for negotiators here. So we want to thank you all for your great inputs. And we want to wish all those traveling to Ottawa a fruitful negotiation. There are a lot of resources that will be available on the webpage of this event. So the video is already there. We also have on our website various pages and resources, a list of events that are taking place in Ottawa starting already this weekend, with a lot of stakeholders trying or working to have an ambitious outcome of what will take place in Ottawa. So once more, thank you all for your inputs, and good luck for who will be in Ottawa. And see you also once Ottawa negotiation is finished. We would be very happy to have you back while we prepare INC 5. Thank you all.